I don't know, somewhere between my third and fourth year. Um, and today we're going to be talking about MATLAB. So I'm going to approach this as if you have never ever touched MATLAB before. Um, if you have experience with any other programming language, then MATLAB's probably going to be pretty easy. It's based on C. So, if you want to use things like if loops or while loops or for loops and things like that, things like classes and global variables and everything, that all carries over here. It's a higher level language. I would almost consider it kind of like a more like a scripting language than an actual like real programming language. Although if you do have more experience, then you can get into the nitty gritty with using MATLAB and being able to interact with the different functions that are already built in. So before we get started, just real quick, so I know who my audience. I know Daniil. I don't need everybody to introduce themselves, but I'm assuming most people are EE majors. And then if there's anybody who's maybe different, maybe just speak up and just let me know so I know if there's somebody who's not who I'm expecting.
I found out about this event through the AESB Discord, and yeah, I'm doing computer science, but I'm thinking of changing my major to computer engineering technology.
Okay, cool. Yeah, the only reason I asked is just because, like I said, this is going to be like a real brief, well, not brief, but just real basics, right? I'm just going to talk about go over the actual editor, starting just, making variables, things like that. And I bring that up because for electrical engineers, we are required to take a MATLAB course. So you're going to take a whole semester of learning how to use MATLAB. And then basically for all your classes, especially the 300 level up, even if you aren't explicitly asked to use MATLAB to do a particular like homework assignment or something like that, you'll probably end up using MATLAB just to help you check your answers, because it is a pretty powerful tool. Okay, that's the only reason I brought that up. Excuse me. So,
oh, Ben, I don't know if you saw the chat, but there's a few people that are CS and mechanical engineering too.
Okay, sorry, I don't have it up. So let me give me just a second. Is it okay? Let me bring this over here. Okay, cool. So yeah, that's great. Glad to have you guys. Sorry about that. I didn't have it broken out, but here, give me a second. Let me clear my throat. Okay, so getting started, I have the web-based version of MATLAB on my screen right now. There is an actual program that you can download and install as well. So, as long as so when you first go to the MATLAB website, if you log in with your school email, then Long Beach has the campus-wide license. Oh, it automatically went there, but it has the campus-wide license so that you can not have to pay anything. So you guys would say you don't have an account. If you haven't done this already, create one. You'll have to register with your school email, and then once that gets validated by MATLAB, you can either log in through the web-based version, which I personally prefer, and I'll go into reasons why. But I know some people, whether it's because obviously you need to be connected to the internet for it to work. So if you need to work offline, or you just don't prefer the way that the UI is set up for the online editor, the install version is definitely a good thing, a good tool to use as well. Okay. Okay, just bear with me while I get back in here. Okay. So I personally am going to start predominantly use the online version because that's where most of my stuff is saved and that's where I'm comfortable with. If I feel like I need to go back and show a difference in the offline version or the installed version, or you guys want me to do it in this version, just let me know, and then we'll go over that. Okay, so we open up MATLAB for the first time. Obviously, for you, you're not going to have any files here saved, but this is basically what it's going to look like. So just going over how the window is set up. This is where all your files will be saved, where you can see them, and so on the installed version, you can see that it actually has a directory on my computer where all my files are saved. So this big window right here in the middle, this is the command window. So here you can type in just like as if you were using the command line, like in DOS or something like that, right? Excuse me. So this down here, it's called the workspace. So whenever you create a variable in MATLAB, it's going to show up down here. You'll be able to see the name. If it's a, so I just made a single, I assigned a single number to X, and it'll show up there. It'll show you the size. Now, if you didn't know, MATLAB stands for Matrix Laboratory. So one of the things that makes MATLAB so powerful is the fact that it's intrinsically deals with arrays and matrices, right? So with like a different program, like more lower level language like C, if you have to deal with matrices or you want to create a matrix, you have to use loops. So with MATLAB, we don't have to do that. You can if you want. It's not efficient because of the fact that MATLAB, like it says, by design, is supposed to deal with matrices. And so that's also part of what this icon here to the left of the variable shows. It will show you the type of variable that you're dealing with. So there's other types of variables that I'll end up showing you. And you'll see that the icon here will change. But this just shows that this is some sort of array. Even though it's a single number, it can still be considered, you know, a 1-by-1 matrix technically. Okay. So in MATLAB, I'm sorry, let's go over the rest of the window. So these three tabs up here are here by default. They'll always be here. Depending on what different windows we bring up here in the middle of the screen, additional tabs will show up, but these will always be here. So the big ones that you need to be worried about is just the home one. So most of these buttons can be also be used by using commands in the command window. But the one that you're predominantly going to be using is going to be the new script. So as you see, it shrunk down my command window and it made a new tab here where I can type in, and then when I create another variable, okay, so it actually saves it. So this is as if I'm in like a notepad text editor or something like that. And also one thing to keep in mind is that the actual, so once you create scripts and you save them, they're going to save them as .m files here. And these are just text files. So if you were to open, give me just a moment. If you were to open up these text file, those .m files with a notepad or some other text editor, then it will show you exactly how it would display in MATLAB. So if you don't have MATLAB on a computer or something's going on with it or whatever, you just want to edit it in some sort of notepad program, you definitely can. And then when you save it and then you open it in MATLAB itself, then it will, however you have it formatted in that text file, it will show up there as well. Okay, so as you see, once I create a script, new tabs appeared. So the editor tab is where you need to be if you want to do any sort of function when you are creating a script. Okay, so we have new, save, that should be pretty self-explanatory. So I'll even talk about the stuff here on the right here, so run. So once you have your script completed, and actually let me bring one up just so that I'm not just I actually have some real data to show you here. Give me a second. I'm just going to pull up one of my. Okay, so this is a assignment that I'd done previously. I'm going to use it as an example. I know there's a lot of text here. Don't worry about it. We're going to go over all of it, and I'll break it down, and we'll take it piece by piece. Just an example. So I have a completed script here, and when I click on the run button, then it's going to execute everything that's in the whole, like this whole entire tab, line by line. It's going to take some time just because of the functions that I'm using, but I'll keep talking. The other thing that you'll probably, or at least that I personally use, is the run section. So the run section, you notice here that I have, excuse me, that I have these double % signs here. So if you have these added in, it will section off parts of your code. So because I have this double % sign here, it separates this top portion with the bottom portion down here. And that's great. Like if you only want to execute a certain part of the code to be able to separate them. And then also when you go to publish, like if your teacher wants to have you print out your script or what have you, then if you whatever you put into the title here, it will display as a like a heading, and I'll show that later on once we get to publishing. Okay, so we see that the script ran, and so now we have more windows here. So in my script, I had it create some graphs, and so once it finished executing, it created those graphs. So graphs in MATLAB, they're going to be called figures, and then once you click on the figure, we see that now we have a figure tab. So this is just one thing that you need to keep in mind. If you have if the last window that you clicked on was figure, then that's what the tab is going to be. And then if you're trying to be like, well, where did my editor tab go? Up here at the top, you just need to actually click in a script window, any script window, and then that will come back. Okay. Okay, that's all I wanted to talk about right now for that. Okay, so just again, I'm talking about the windows, and then we'll get into the code in just a bit. So you see down here in my workspace, I have a whole bunch of variables now. We see that some of the icons have changed for some of the variables. We have this block icon, and again, I'll go over that in a little bit. What I want to focus on now is, so say I wanted to save this data, right, and then use it for either another script I'm going to be running, or just because I wanted to have it because I want to save it for a report or something like that. So you can either, if you right click, you have to do it in like an empty space if you do it by right clicking. But if you right click and you click on Save As, then you can save the whole entire workspace as a file, and it will save it as a .mat file. And let me go back up, because I'm pretty sure I have a few. Yeah. So I have some previous workspace variables saved. And so I'm just double clicked on it. And then I'm not sure if you noticed, but now my workspace has all the other additional variables. So if you already have variables in your workspace, and then you open up a saved workspace, it will just add it in there. It won't delete the current variables that you already had. Now this is getting kind of crowded, so let's talk about some functions as far as like dealing with the windows in MATLAB. So there's a few commands. You can either, like I said before, the commands I'm talking about are up here as well. So the clear workspace, if you do it, then it will delete all the variables that are in your workspace. You can also just come down here to the command window and then hit clear, and then it will clear it out as well. And then another function, so as you're executing code, MATLAB, if it runs into any sort of errors, or if you tell it to display certain functions, and I'll talk about that in just a second, it will input text into the command window. And so if there is a bunch of text and you want to clear it out, you just type in CLC, that will clear out the command window as well. So normally when I personally run my code, I usually tell MATLAB to clear out the workspace and clear out the command window. Obviously, there'll be times where you don't want that to happen. But if you execute it at the top of your, or you put in those commands at the top of your script, then obviously, because it starts from the top and goes down to the bottom line by line, then it will clear everything out. Same thing with the CLF, that is for clear figures. So if you type that in, then that just clears out the figures, clears out the plots that are in the figures. It doesn't actually get rid of the tabs themselves. And then I'll talk about hold off in a little bit when I talk about plots. Okay, so let's go back to just the command window. And we'll come back to that in just a second. Save changes, no. All right. I'm just doing this just so that we bring the command window back up. Okay. Oh, and one more thing. So I should have left that, but okay, that's fine. So you notice that when I'm typing something in and I'm done with what I'm trying to assign to the variable that I'm creating, in this case it's x, I'm putting a semicolon at the end. So that makes it so that when the line of code is executed in the command window, nothing appears. So since I'm in the command window and I executed this line, you notice that nothing displayed here. But if I was to type it in without the semicolon, then it will actually show it. Okay. Okay, so talking real quick about naming variables. So MATLAB is case sensitive. Okay, so lowercase x and uppercase x are considered two different things to MATLAB. So you see down here we have two different variables, one that's capital X, one that's lowercase x. So you want to make sure that you be careful about that. As far as white space, MATLAB doesn't care, so I can put in, I can put in no spaces, and MATLAB's perfectly okay with that. With naming variables, obviously, if this is the first time that you've been dealing with like coding or any sort of scripting language, you want, if I just made everything be like letters or numbers or something like that, it will be hard to read, especially if you want to go back and read your own code. I know some of the stuff in here has been 2-3 years since the last time I've dealt with it. And so if I was to go back and all my variables were just letters and numbers, it would make it really hard to read. So obviously you want to make sure, even if you're not going to be sharing your code with anybody else, it's good practice to make sure that you use good names for your variables so that you always know what you're dealing with. Let me go back. Okay. So you notice here that I have green text here. So these are comments. And to make comments in MATLAB, all you need to do is put a single %sign. And then, obviously, if the text is in green, then that means that it's a comment and that MATLAB will not actually execute that as part of the code. If you want to comment out large portions of data, then you just highlight whatever you want. And then the easiest way is probably just to come up here and click on the %sign, and that will comment out the whole entire line. You can put multiple comment lines if you want to. And then if you just press the button next to it with the blue X, then it will delete each column of the comments. Okay, so one thing that that makes me like the online version of MATLAB more so than the online version is that the online version has it's auto-suggestion, right? Okay, so you notice here I deleted a variable. This triangular pulse is a built-in function of MATLAB, okay? So it's there by default. So MATLAB knows that there's certain arguments or certain terms I can put into the parentheses to make it execute this command in a certain way. So when I delete it, if it will tell me what is the like a possible suggestions that I can put into here. So I can put in, you know, a number, a vector, a matrix, et cetera, et cetera. So, and then once you start typing in something, if it's, it will give you suggestions based on, you know, obviously what you type in here. So if I'm going to put in the letter or a variable for my workspace, it'll show me that. And then also it, when the FX, these are built-in, the icon means that this is a built-in MATLAB function. And so it will also give me that suggestion as well. Now, my version of the install version, or the program of MATLAB on my computer is 2018. So the current version is 2020. I don't know if that has been integrated into the 2020 version, because once I switched over to the online version of MATLAB, I basically stopped using the installed version since then. So maybe the auto suggestion is in there, but again, that's just one of the things that I really like about using the online version of MATLAB.
The auto suggestion, sorry to interrupt, the auto suggestion
No.
is in the IDE version. So
okay,
it should pop up too, yeah.
Awesome, okay. Okay, give me just a moment. Okay, and all right, I'm sorry, so let me stop and take a second. So as far as the level of math for everybody here, has everybody at least dealt with matrices in some capacity, like, you know, like matrix multiplication, things like that? Or is there anybody that hasn't dealt with matrices, I guess is the better question? Okay, so we have some people in pre-calc, that's fine, okay. The only reason I asked is because obviously, like I said, with MATLAB, it's by design supposed to be using, naturally uses arrays and matrices. So if you don't know how to use matrices and arrays, there might be some things that aren't intuitive to you. So let's go ahead and talk about that. So give me a second. Let me go back and get something here. Okay, so ignore this bottom portion. Let's just focus on the top portion up here. So I made a matrix, and okay, I'm sorry, real quick, just so that, let me preface this because this does look different. So you notice up here, this tab in the editor, it's just a .m. So this one is called a .mlx. One thing that MATLAB is trying to start to push more and more, it's called their live scripting. So it's basically the same like text editor with added features. So you notice here that on the left, it has all of the outputs for the code that I have here on the left. It'll do that automatically. If you can section out, so instead of having to use like the $% sign to section out lines of your code, if you go to the live editor tab and then you just click on section break, it will automatically create the sections for you. And it's I honestly started using it last night when I was getting ready for this, just because I saw that it was available, and it's pretty cool. It will also show you line by line as it executes the code. So you remember when I first executed this example here, it kind of like paused there for a second. That's because right here, it was doing a lot of calculations, and so that was eating up a lot of the time. So if I was to run this in the live editor, you would see here, it would actually have like this little bar here on the left that would be moving to show that it's loading. So it'll show you like parts of the code that it's executing at that time, and then it'll show you here on the left. And yeah, it's kind of nice. It's not a text file, obviously, because there's the more features, so it's not as easy to share or use because you can't use the notepad with it, but it's definitely an option because it does make the code look cleaner, and it makes it easier to know what's going on as MATLAB is executing all the lines. Okay, so going back to talking about matrices, the by default, MATLAB will put things into rows and then columns. So what I mean by that is that if there's any command that is designed to interact with vectors, and when I say vectors, I mean any sort of matrix, because you can have a vector that's just, one row, just like in like you're dealing with calculus, or a vector could be an actual matrix. So when you're dealing with matrices in MATLAB, you always need to remember that it's rows first and then columns. Now, excuse me, if you want to create a matrix, there's a couple ways that you can do that. And so first we're going to start with just a vector. So you can either, you always want to use brackets, okay? Now, when you create a vector, you can just put in the numbers like this, space them out. You can put in commas, and then spaces or commas mean the exact same thing. And so if I was to run this, it's going to run the whole entire thing. So we see here, I have a 1x4 vector, okay? Now, say you don't want it to be a row vector, you want it to be a column vector, right? So then if that's the case, then you use semicolons. And so when I run it again, we see now that I have a 4x1 vector. So it's just one single column. Now, as you can see up here, I have an example of a matrix. And if you combine either spaces and commas and with semicolons, then that's how you can create a matrix. Now, for right now, I'm just going to use the command rand. So rand is a command that creates a random number, and it's from 0 to 1. So if I make a rand, let's say rand 5. All right, so what this is telling MATLAB is that it's going to create a vector that's 5 by 5. Okay, so it's always going to make a square matrix. Wait, real quick, let me make. Okay. I'm not sure why it's pausing because it's not giving me an error, but it did make the matrix.
There's a comma.
I'm sorry?
There's a comma. You put a comma, so it's not echoing.
Oh,
Yeah.
Thank you. Okay. So when you make the okay, here, let's try this real quick. Stop. Here, let's just get out of the live editor.
Oh, Ben, I think your problem is that you have it a breakpoint selected for 9. So if you go to the right, you see that 9 is clicked.
Oh,
if you unclick it, so if you hit step at the very top, it'll go through the code. So you inserted a breakpoint for like debugging.
Oh, because I clicked on 9.
Yeah. So it's stopping the code
okay.
at 9. Then you would just step through it. Yep.
Awesome. Okay. Thank you. Okay. So we see now that it made the matrix on the left. Okay. So if you just put in a single number, it will make a matrix that's n by n. So in this case, it would make a 5 by 5. And then if you were to specify, a second number, then it will make in this case, a 5 by 3 or 5 by whatever matrix. So there are other functions in MATLAB. There's like, if you say you wanted to create a matrix of zeros, the function is just zeros, and then it follows the same convention. If you just put in one number, it will make a square matrix of that number. And then if you specify the columns, then it will make it that particular size as well. And then there's also a ones as well. So it works the same way. Is you just put in ones, and you put in exactly how big it is, and then it will create a matrix of that size. Now, if you want to create, so say going back here, okay, so you see right here, I know this is a little confusing because I'm using variables, but I made a vector, okay? So here I just predefined, and actually this is a good point. So basically in anything that you're creating in MATLAB, whether you're creating vectors or matrices, or you're actually using and like different commands, as long as the variable here, so here I have a variable named TS, as long as that variable exists in the workspace, or it will execute in the line above somewhere, on the line that it will be using that variable, it's interchangeable with a number. So you don't have to, put in actual numbers for it to work. It will always be able to reference the variables as long as they exist in the workspace before that line, that particular line is going to execute. So going back to here, let me go to the command window. So if I wanted to create a vector, say I wanted to create like a time variable, right? Then you can do that by using the semicolon here. So this is going, if you just use just the semicolon and you put two numbers between it, it's going to make them be evenly spaced, like so, single integers. Okay. And then if you want to dictate the size of the interval, so the distance between the first element and the second element in your array, then you do that by putting in a number between your starting number and your ending number. Okay, so now I have it increments in 0.5 steps. Okay, now you notice that when I did that, it automatically, this does not allow me to control how many elements are in the array, because instead of choosing to do that, I'm choosing how big I want the step to be. So there's another function in MATLAB called linspace. So linspace will automatically will allow you to define how many elements are in your array and then it will automatically choose the interval instead of you choosing the interval and then it automatically deciding how many elements are going to be in there. So say 50. Okay, so by default, if you don't specify, if you only put in two numbers, so this is my starting number and my ending number, it automatically is going to make the array have 100 elements. You can see here, because it's a single column, right? Pretend this line just went on forever and it didn't actually go to the next line, right? So there's 100 elements in my vector now, X, okay? Now you can choose how many elements are in there by putting in one more number here, and it's called n. So say I wanted only, I don't know, say 40. Right, so then now it's created a vector with 40 elements, and then it automatically chose the interval between here, right? So that's why we have, so apparently it's 0.2308 is the interval between the elements. Okay, now talking about elements, so MATLAB uses, because there are some programming language where you have an array and it's like the very first element in the array is considered like the 0th element. MATLAB doesn't do that. It considers, it starts with 1, okay? And that is important to know because the next thing that we're going to be talking about is going, well, actually, let me finish talking about a few more commands with matrices, and then I'll talk about indexing next. So we created a matrix here, and this is just a 4x4. So say you had just a column a row vector, right? So we made Let me just make one real quick. Okay. So I have my row vector. Now, if I wanted it to be a column vector, instead of having to make a new vector and putting in semicolons, you can just use the apostrophe. So if you use the apostrophe, that will transpose your vector. Okay. So if you have a column vector, I'm sorry, if you have a row vector, it'll make it into a column vector. And then if we take, here, let me go up here. This is a different variable. I'll just call it U. Okay, so I'm only showing this for people who, like I said, haven't dealt with linear algebra before or matrices. So we see that if we transpose a square matrix, it takes the columns and then makes them into the rows, right? So it takes this column and then puts it into this row, takes this column, puts it into this row, and et cetera, et cetera. And so, you know, there may be times where you need to deal with like change matrices from either rows to columns or vice versa, or maybe deal with square column, or I'm sorry, square matrices. So the apostrophe is how you would do that. And okay. So now let's talk about indexing. So indexing allows us to call it, if we just wanted, say, so down here, going back down to this example, if we only wanted to call it a certain element, say like the fifth element, right? 1, 2, 3, 4, 5. Say I wanted to specifically pull the fifth element from the array. You would do that by, oh, here, I'll just do it down here. So this is still X. So if you have your vector, okay, whatever the variable ends up being, and you put if you put parentheses next to it, then you can call what element you want from the vector. So if I wanted the fifth element, then it'll tell me. So this tells me the have a number. I'm sorry. Let me go to my workspace real quick. Okay, yeah. So I'm sorry, I confused myself because it calls it based on what's in the workspace. So yes, I had this named a vector of 100 elements or of 40 elements, but then I changed it because I ran this piece of code. So it changed the variables or the numbers that were stored in the variable X. So I called the fifth element, so and then it told me what the fifth element was, and it was 5. And we see here that that's correct. So here, let me use. So say I wanted to call a certain element within a actual matrix. So we see here it automatically shows us, because it knows that this variable here, mat_x, is a matrix. It automatically tells me that it wants the rows and then the columns, just like we talked previously. So say I wanted the second row, third column, and then it tells me what that is. So if we open up mat.x and then second row, third element, we see that that is correct. Okay, is the 0.6797. Okay, so say you wanted to call, or you wanted to extract a whole entire row. Okay, so going back to our matrix, to do that, you're going to use a semicolon. So what the semicolon does when you're calling a vector or a matrix is that it will call, or it will pull the whole entire, everything that's in, so all the rows, right? If you put it in the first spot, and then obviously if you had put it in the second spot, then it will pull all the columns. So when I do this, it's showing me So it's showing me all the rows in the third column. Okay. Okay. And then if you were to call a just a single number, so we're doing it in a square matrix, it only gives us one number. So if you put in, if you're indexing a matrix with a single number, it's going to call it, it's going to do it column by column. So to MATLAB, this one here is 1, 2, 3, 4, 5. And then if you put in a number higher than 5, it's going to go to the next column, 6, 7, 8, 9, 10, et cetera, et cetera. Okay. This is just something to keep in mind. You need to be careful when, like, what you're trying, like, that you know what you're trying to index, whether it's a matrix, whether it's a vector, you know, just like a single row or a single column, because depending on what type of array it is going to change how it calls the different pulls the number from the variable. Okay, so let's keep talking about arrays. So for those who don't know, if you have a matrix, if you're trying to multiply two matrices together, their inner dimensions need to be the same. So what I mean by that is if you have, say, a 4×3 matrix, and then you have another matrix that, if you want to be able to multiply a matrix with this matrix, then the matrix needs to be a 3 by whatever, right? So the columns of this matrix need to follow, or it needs to be the same dimension as the rows in this matrix. And so MATLAB works the same way. Let me see here. Let me make this be 4. So then if I was to multiply u times x. Okay, so it gives me an error, and it tells me that it's incorrect dimensions. Now, if I was to flip it, because then we have x, which is a 1×4, and then we have u, which is a 4×1, so the inner dimensions will agree, then it should work. Okay, and then we see here that it shows us what the values would be. Now, if you want to take a scalar, so a single number times a vector, that works just fine. So say I want to do it by like 56. It executes that. Now, what you can do is that you can do element-wise operations, like so element-wise arithmetic on a matrix. So what I mean by that is that if you want to take so in this example where we have our 4×4 matrix, we can take our vector here, our row vector, and then it will do it, it will multiply element by element between the two matrices. And so the size doesn't need to be, doesn't need to match. And so to do anything element-wise, you need to put a period before the operator, okay? So it doesn't matter what the operator is, any arithmetic will work. You just need to make sure that you put in the period, and then it will do it, do the operation element-wise. So let's go ahead and show that. Okay. So you see right here, it basically took the first element here and it multiplied the whole entire column by it. Took the element here, multiplied the whole entire column by it, et cetera, et cetera. Okay. So the next thing that we're going to talk about is if you're using certain functions, so going up here to get a output from a matrix. So what I mean by that is if you want to, okay, so for example here, I have the mean. And if you do it by default, if you just use a command, it's going to do it again by the columns, okay? So let's show a different example. So say there's a different another command in MATLAB where you can extract the size. So let's go size of x and call this U. So if you just put in if you just put in the single variable, it will it will call it for that particular vector or the array that you put in. So what and we see out here that it outputted it be a 4x4. Now I'm sorry, so I lost my train of thought. So what I was actually trying to say is that you can tell MATLAB. Say we only wanted to know what the size of the rows are, like how many rows or how many columns, right? So what you can do is that if you know that a function will give you multiple outputs, so in this case it gave us 2, then you can tell MATLAB which outputs that you want to actually be shown. So in this example, we'll say like U rows and U calls. Okay, so now, unfortunately, this is something that you're just going to have to learn because there's way too many functions for me to be able to go over each and every single one. But, and also another nice thing to bring up, the documentation for MATLAB is actually, it's pretty good. I honestly still reference it all the time. So if you have any sort of question or if you don't know how to use a function, if you just type it here in the documentation, then it will bring up a new window. Not only will it show you like the actual MATLAB documentation, but it pulls like posts from their forums. And then if people have like their own code that they've uploaded to MATLAB, that's what the file exchange is. So this is a really good resource. Like I said, I still use it all the time. Because it's definitely, MATLAB, there's so much to MATLAB, like just like with any programming language, it's hard to remember everything. So as long as you know how to find it, then you'll be able to, keep trucking along. But so here we see that it goes, it defines each and every, all the different arguments that can be inputted into the function. It gives a brief description. You can even open up examples that it has, and you can interact with it yourself. So that's definitely something that you'll probably be utilizing a lot. But going back to our example here, so now that I've told MATLAB that I explicitly wanted to extract the information, so not just tell me that it's a 4x4, but actually the outputs that it will be giving me here to assign it to variables. So that's what I'm doing here. I'm assigning so for this particular function size, it gives the size of the row first and then the size of the column first. So when I execute that, we see now that 4 has been assigned to U rows and 4 has been assigned to U columns. So if you know that the function gives out multiple outputs, then you can tell MATLAB how to output those, how to assign those outputs if you so choose. Now, like I said before, say we only wanted the columns and we didn't care about the rows. If we wanted to do that and only get the rows, then if you put in a tilde in the brackets when you're requesting or trying to assign the outputs, then that will basically tell MATLAB to ignore it. So now we see here on the right, it only assigned the variable calls because we told MATLAB that we don't care about the output for the rows. So there's other functions like there's size, and then there's also max, that will tell you the maximum elements in an array. There's min, Probably one, if you're any sort of engineering that you'll probably end up using is cart to pool. So as it tells here in the little pop-up, it takes Cartesian coordinates or rectangular coordinates, X, Y, Z plane, and then it'll change them to polar, or if you're dealing with 3D, it'll change it to cylindrical. So if this was actually if my matrix was a matrix of like rectangular coordinates, then it will give me it does it by, for cart pool, it does it by the angle and then by the magnitude, right? So it would be basically be, this row one would be theta, and then this one would be R. Okay, and I'll show that here because I think I use it in here. Yeah, I do use it in here. So I'll show it here later because I'm going to actually go over this line of code as well. Okay. So next thing we're going to talk about is plotting. Obviously MATLAB is really good at processing and computing large amounts of data, and then usually you're going to want to visualize that data in some capacity. Let me, because I have one saved here. Actually, I think I saved it here. Let me find it real quick. Okay. So with plotting, the basic command to plot is to use plot is just plot, and I'm just going to extract this particular line here to show. I need to run this first. Okay, and then so that's one thing that's different with the IDE version, is that it will actually output the figures as a separate window instead of doing it within the browser, just because of the the limitations of the online version. Okay, let's minimize that. So if I take back. There we go. I just wanted a single. Okay. So again, with how the functions are called, you're going to put in the row first, or the x-axis in plot, and then you're going to put in the column or the y-axis in the second comma. So obviously this plot is, it's pretty bare. Our axes aren't labeled. There's no title. We don't have a legend since we have multiple lines. We probably want to show that to be able to identify which line is which. So as we can see here, there's a whole host of additional functions that can be used in conjunction with plot. So if you want to use them, you need to make sure that the plot is created first, okay? So if you're executing the code, what that means is that these functions need to be, cannot be above the plot line, because it will create them, but then as soon as the plot is created, it erases all of them, okay? So you need to just make sure that you keep that in mind. There are ways to format how the text is actually displayed. So again, or not again, but you notice here how inside of here, the text is purple. So usually if you see purple text in MATLAB, that means that it's actually going to display this text in some fashion, whether it's on the graph, or if you're going to publish it and you're wanting to actually print out like lines or sentences, things like that, to actually show in the published document. It will all be in purple. Your best bet is because again, there's simple ones here: title, X label. Obviously, this will label the X-axis. Y label will label the Y-axis. Grid on creates a grid on the actual graph, as we can see here. There's a whole bunch of other functions. If you go up to the documentation, and I believe it's line properties. Let me double check real quick. Yes, line properties. If you go to line properties, you'll have it load. And then you just click on chart behavior. You know, it will go over all the different commands that you can use. To go over a few other things right now. So with after you input your data, if you want to change like the color or how the line is displayed, or if you're dealing with like discrete points and you want to show markers, then after you put in what variables that you want to be plotted on the graph, then you just use quotation marks, and then say we wanted the line, and we're only going to deal with one plot. Say we wanted the line to be red, and I wanted it to have dashes and then X's. And now if we run this, give me a second, let me close that, let me try it one more time. There we go. Okay. So we see here now the line is red by default, because MATLAB, if you don't specify a number, it will just automatically choose the colors for you. And then we can see here that, so each actual discrete point has an X, and then between there are lines. Obviously, it's harder to see because the X's get closer together towards the curve. But yeah, if you wanted to change that, that's how you would do it. There's also, you can change like the thickness of the line. So that would be line width. So you could use that as a, and then I believe, here. Sorry, give me just a moment. Okay. Okay, I'm terribly sorry. I'm drawing a blank right now. I can't remember the command for the change in the line width. I would have to look that up. But continuing on. So let's talk a little bit and about a different function or a different way to use MATLAB. So up until now, we have been using actual discrete numbers. So another way that you can use MATLAB is symbolically. And so that's actually what's called like a different toolbox. And so there's a whole host of different like plugins that you can add to MATLAB. Our campus license should have the symbolic toolbox a part of it by default. So it's not something that you would have to like try and reach out or get on your own. You should automatically be able to use it. And so what the symbolic toolbox allows us to do is that it allows us to deal with functions as if we were using like continuous lines or continuous variables. So, obviously everything that we do is on a computer. And so a computer doesn't know how to, or doesn't by default, isn't able to deal with like the idea of infinity, right? Because it only has a finite amount of memory. And so it has to be able to deal with things as discrete variables or numbers. So the symbolic toolbox allows us to better interact with that. So when you use the symbolic toolbox, you need to start by using this command sims. So what this does is that it defines to MATLAB what our variables are going to be. So for example, say we were going to do like a derivative or like an integral, right? And we have to integrate or differentiate to respect to a variable. That's where the sims_t or defining this variables with sims comes in. So let me bring up an example real quick. Okay, that's fine. I thought I had it saved. I don't see it though. So let's just make a new script and we'll just do it from scratch. Okay, so I'm going to do sims_x, and then I'm going to define a function. Let's call it wave1, and I'm going to make uh, 0.1 to pi, and then let me save. And then I'm going to call this output sine of wave. Every time that you make changes to your code, you need to make sure you save first before you run, or it will ask you to save it again. Okay, so what I'm going to do, I'm going to Okay. So first, I want to show this first with showing the derivative, or taking the derivative here. So I know somebody said that they were in pre-calculus. So the derivative is just basically like the slope or the rate of change for a function. So what we did here is that we defined an interval. We created a vector that went from -pi to pi. That was an interval of the 1,000 steps, and then we took the sign of that. So that gave us a vector f that is the sign of our x. Okay, and then if we were to plot this, here, let's we want to plot. So we're going to plot x first. And then here, let me just do this. Okay, so we made a plot of the original function, and then we showed the other functions as well. So the red line is our x, so that's the original function, and then we see here. So our next line, we made it in blue, so that's going to be the blue function. And so that's going to be our first derivative. And then since we took the derivative of the first derivative, that would be the second one. So then that's when our black line is shown here. Now, we're going to use a different variable. So we'll call it t. And then here, let me show. Okay. So we're going to define a variable named EQN, and then so we see here that when we took the sign of it, our EQN, when it showed up here as a variable, we see that it's not like a discrete number anymore, and that MATLAB calls it a symbol. Okay, so if I was to expand this here, it says a 1x1 sim, and then we see that the icon here changed to be that block. So any icon that has this to MATLAB, that particular variable is a symbol, and so it's not actually a discrete value. MATLAB treats it as if it was like an actual function. So as if we were taking like sine of x, and in this case, I just named it sine of t. Okay, so then if we were to take the derivative of it, so I'm just going to call it dx EQN, and then I take the diff of EQN. Okay, now, and that's now we see that we have another symbol here. So the way I'm going to show this is that I'm going to plot it. So when you, if you want to plot variables that are symbols, you can't just use the regular plot command. Okay, the command for symbols is going to be F. So in this case, I'm going to just plot our derivative of sine, and so here we go. And we see that it shows us a continuous line, and then it also, well, because I didn't close the line with semicolon, it also so it actually shows us the answer down here as well, that the derivative of sine is cosine. So that's just one thing that you need to keep in mind when dealing with symbols. It is very powerful. You know, like I said, you can integrate, differentiate. We see here in my the homework example that I'm showing you, I'm actually using Sims to create a triangular. It's called like a hat function, right? So you just need to be bear in mind like the types of variables that you're using with either plot or fplot. And that you don't get them confused if you're dealing with a symbol or if you're dealing with an actual vector of numbers. Okay, one more thing that I want to talk about with plots. So, especially at least with electrical engineering, you will have to be dealing with log units. And so you're going to want to be able to know how to do that. So I'm going to go ahead and run this code again in its entirety. Bring back up the plot. Give me just a second. Okay, so, and also we'll talk about how we got MATLAB to show all the graphs in one figure. So there's another way that you can, there's another plot command that you can use called subplot. So what the subplot does is that it will divide up all the plots in a single figure window and display them in a certain manner. So how that manner is decided is by the variables that you put into the subplot command. So basically, again, with everything in MATLAB, it starts with rows first and then columns. So what we're telling MATLAB when we use subplot 2, 2 is that we want 2 rows and then that we want 2 columns, okay? And then what that last number dictates is where in the window that particular plot is going to be displayed. So we see here that it goes from 1, 2, 3 to 4. So the corners are numbered as such. So you see that also helped to name the plots to make it a little easier to see. So this corner is considered 1. The top right is 2, 3, 4. So it goes in a clockwise fashion. Okay. So if you have other plots, so say you had like a 3x3 or 4x4, same thing. It would be 1, 2, 3. So we'll just keep subdividing it just like kind of like a clock, right? So we see here, this is all 4 of these graphs is the exact same set of data, just plot in different manners. So this plot right here is just with no log, okay? So we see here that the plot command was just used to graph the 2 data sets. Now with, for the next one, so for this graph right here, if you look down here, right here, you see that the command is used as not log. This time it's semi-log x. So what that means is that only my x-axis is logarithmic, okay? My y-axis is still just normal, okay? And then vice versa. So here we have, this time the y-axis is logarithmic, and then the x-axis is not. So the command for that is still semi-log, but this time instead it's just going to be y. And then of course, if you want to have both axes be logarithmic, then scroll down a little bit. So the command is going to be log. So log for the x, log for the y, and then that's how it is going to display here with both units being semi-log. Okay. Let me go back to this real quick because there's one thing I want to mention about plots before we continue. Okay, let me fix something real quick so we can show. Like that. Okay, so one more thing in regards to plots, we see here that I actually have like figure 1 above my plot function. So if you want MATLAB to output plots to certain figure window numbers, then you can explicitly state that. I normally do this anyways, because if you don't put the figure in there, it will still create the plots. I like to tell MATLAB explicitly what figure it goes into what plot, just so that if something weird happens, then I know, like, it can help with troubleshooting and trying to figure out where the issue came up. Now, another way that you can do this is that if you don't use the plot command, so say I wanted all 3 of my plots. So I have a plot here, so I'm using subplot, and so technically these would be one graph, and then I have this plot up here. So if I don't have the plot, the figure command in, another thing that you can use, if you say I wanted all these on the same figure window, then I can use another command called hold on. So what hold on will do is that once it, whatever is like the last plot command that is above hold on, it will execute, or it will create that plot, and then it will hold it. So by default, MATLAB, if it sees this next, these next plot commands without that hold on, it will create them in a new figure. But since I'm telling it to hold, then it's going to make it all in one graph or one figure window. And then the way to turn that off is using hold off. Okay, so we'll go ahead and give me a second. I have to get to the right window or my right folder. Okay, save. Just got to give it a second because it's running. So while it runs, let me talk about some other stuff. So same thing down here. You see that I'm indexing my y-axis, and then I'm telling it to do all the rows, and then only the columns 1 through 20, because DMAG has a lot more than just 20 elements in it, or has a lot more than 20 columns in it. So again, you can use that kind of stuff in any sort of function, including the plotting functions. Okay, so so we see here that there are some errors, and so as I was saying previously, if MATLAB encounters any sort of errors, it's always going to output them to the command window. So what ended up happening is, I guess everything couldn't fit into one figure. So we see that a separate figure window wasn't created, and then it just plotted the subplot that I defined down here into figure 1. So let's just go ahead and take that back off. Put back in my numbers. I'm not going to run it again, but okay. So yeah, just bear in mind, like I said, I honestly think it's a good idea to keep you to make sure that you define your figure numbers, because then you know like where it should go instead of letting MATLAB decide, because sometimes it can do some funky stuff. Since it's shown here, I'll go ahead and talk about it. So there are other ways to plot graphs in MATLAB. We see here that instead of using plot, I'm using a sten command. So what that does is that it takes the data, and then it makes, instead of making a line trying to connect the dots, it creates stems for each data point. And then I'm gonna break it up just so because this part of the code executes a lot faster. It needs mags. Okay, I'm sorry, I'll just run the whole thing. Okay, give me just a moment. Okay, sorry about that. Okay, so if MATLAB is running, or you think it's running, and it seems to be like you want to kill it, and one thing that you can do is that once you're in the command window, you can hit Control-C, and then it will stop at whatever line of code that it's executing at. You know, with the regular text editor, you can't see that. If you were in the live editor, then you could see what line that you coded at or that it was paused at. Okay. So we see here now, it did start to, it was able to create the first plot with the triangular pulse. With the, like I said, this was a function that is already built into MATLAB. And then, so basically what this does, just to, since it's here, I'll go over it. This is telling the, like where the, so this always makes a, like a hat function like this. So this is telling it where the hat starts, right? Where the hat will come back down. So it's like the hat function starts at 1, it ends at 3. It always starts at 0. And then it tells you where the middle is with 2. And then, so here's where you would put in like you can put in the vector of points that you want to be defined or to make your function. So instead of using it like an actual array, that's when I use the sims to make this be MATLAB treat it like a continuous line. And I do that just because, so this is calculating the coefficients for the Fourier series. So I don't expect you to know that. That's not a, we're talking about MATLAB, not Fourier. But that's what this is doing. And then this was to, since I'm using a symbolic variable when I'm calculating. So this here, I'm using, this is finding the integral of this function here. So because I'm using, so just like in the previous example, when I was using, when I was finding the derivative, if you find the integral with sims, that is allowed, because there's other ways to like to integrate or to differentiate by numerically. There's like the trapezoid method, or there's like backwards Euler, and there's various other types. So there's other commands for that. But for continuous, you just use int, and MATLAB knows to, like, it's able to actually act as if it's able to actually integrate through a continuously between, you know, your A and your B. Okay. So, okay, one last thing that I want to talk about. This is kind of change of gears. So MATLAB, again, you can create loops, right? You can use if statements. You can use for loops, while loops. So a lot of times, if you're going to be creating a loop, let me see, because I have one here. So we'll start with for loops just because I already have an example here. So for those who don't know, for loops, you use a for loop if you know exactly how many times you want a action to be iterated, okay? So in this case, what I'm doing here, like I said, each line is finding a coefficient for the Fourier series. So it's calculating some number, okay? That's basically what all this is doing, right? It's giving me a discrete value. Now, I exactly only want 20 coefficients calculated for my A, which is technically giving me the cosine coefficients for the Fourier series, and this is giving me the sine coefficients for the Fourier series. But so I'm finding it's creating two arrays, right? One named A, one named B. So remember, since I'm have the parentheses with an array, it's going to index. So what this is doing is that starting from 1, it will plug in, since 1 is k up here, then and I have k defined down here, it's going to input 1. So what I'm doing is that whatever is the value calculated by this function or by this operation that I have defined here, is going to put it into the kth element of my A array, right? So whatever ends up being the coefficients is going to be inputted into the first element of my array. So it starts as an array of only a 1 by 1, and then it eventually, as the loop executes up all the way until 20, then it will fill in each element 1 by 1, right? So you always use for loops, like I said, if you know exactly how many times that you want something to run. So the most basic type of loop that we have is going to be an if loop, right? So say I define my x to be 4, and then I say if x equals 4, then we make y equal to 8. Okay, so we run this, and then we see down here, it does, well, I'll actually take this off just so that we see it pop up in the command window as well. So we see down here, since this is true, since x does equal 4, then it executes the code inside. And then if we make x not equal 4, and I keep forgetting to save, it doesn't execute. So y does not change. It does not execute the line of code inside. Now we notice that I couldn't just use like a normal equal sign, because remember the equal sign in MATLAB specifically assigns a value or a range of, like an array or whatever, to a variable. So there are operators in MATLAB called relational operators. So these are doing, they do what's called logical comparison, right? So when I say by logic, it basically decides if something is true or false, okay? So to set something to be, if something is equal to a certain value, then you need to use the double equal sign. If you want to do less than, then you just use a less than sign, or greater than, like, oh, I'm sorry, greater than and then less than. Then if you want to do like less than or equal to, then it's just the less than and then the equal sign. And then same thing with greater than or equal to. So you can use these for your, you'll probably predominantly use them if you're trying to define some sort of loop. So in this case, if I run it, it still shouldn't run, because it's not true. And then with if statements, you can do also define else. So then else with, so what this will do is that if the statement that is being compared is not true, then instead it will execute the code in else. And we see that since x is not greater than or equal to 4, then it then executes this this line of code in here. And then one last thing with if statements, else if. So then we can put in a different command. So you can add in else if. So if this ends up not being true, then the next thing that it will do is test the next else if statement. Okay, and then we see that it executes the code in here and then jumps to the very end. And you can have as many else ifs as you want. So if you had different many cases, then you can keep adding them in and execute the code that way. Now, a lot of the times, at least in my experience, if you're using loops in MATLAB, it's because you're wanting to build some sort of matrix of values based on whatever computations that you're creating. So normally you're probably better off using one of the like the functions that actually interact with arrays, since MATLAB is, like I said, by design able to deal with arrays. But if you feel like you do need a loop, then obviously that functionality is there. The only other thing that the last loop that you can use is a while loop. So if we use while, you define some sort of operator. So as long as x equals 3, actually here, let me do this. Let me say x is less than or equal to 3. So we'll say real quick. Okay, so I'm making x be 9. So while x is greater than or equal to 3, then this loop will execute. Okay, once this statement is not true, then the loop will end. Okay, obviously it happened super fast, but it went through and it actually iterated each time. We see here it did 9 was the initial value. It's since it was still true, it executed the code inside it. Then it went back to the top. It tested it again, and it kept going until x became 2. At that point, we see that the while loop is not true anymore, and then it ended it. So for while loops, if you are unsure or you don't know how many iterations it's going to take for whatever you're trying to calculate, that's probably when you're going to use a while loop. Okay. One more thing. So if you use logical operators or these like these relationship signs actually in your code and not in a loop, then the output that MATLAB gives you is going to be what's called a logical value. So it's basically either going to be true or not true, right? So since we're dealing with computers, it's either going to give you a 1 or a 0. So we have x equal to 9, and then I'm going to say, u equals if x is greater than 8. Oh, too fast. Okay, so because since this is since x is greater than 8, because x is 9, it returns to me a logical value of 1. And then we see here that the icon is different. It's a check, because obviously with logic, it's either true or it's not true, at least in regards to computer logic. And so if it wasn't true, then the icon down here would be an X. So just bear in mind, if you do use some sort of relational operator, like the greater than, the double equal sign, or something, any of the other ones that I talked about, you're always going to get logical values and not like a actual number. So this one is a logical one, i.e. true or not true. Okay. So that's it for MATLAB. One more thing that I want to talk about just real quick, and then I'm going to briefly go over Simulink real quick, just to give you guys a quick taste of it. But so MATLAB by default uses double numbers, right? So what that means is that it's the amount of size, the amount of memory that MATLAB allocates for us to be able to define this number. So a double is means that MATLAB uses, like actual RAM on your computer, uses 64 bits or 8 bytes of data in order to allow us to define that number. And then that allows us to define a number between, I believe it's 10 to the negative 34. So basically, a decimal with 34 zeros, or then up to 10 to the 34. Okay. Now you can change the type of number, or like the size of the variable that you're dealing with if you so desire. I've never had to actually do that. That is probably only going to be important if you're dealing with data that is that's coming from like a different source. And actually that reminded me, one more thing that I wanted to go over is how to import data into MATLAB. I didn't do that and I apologize. But normally, because you're going to be using MATLAB on some sort of computer, and computer nowadays, memory is not an issue. Back in maybe like the 80s or maybe even like the early 90s, data or memory was more of a premium, because I remember like my 1 gig computer, the first computer I had 1 gig of RAM, and back in like 1995, and it cost like $2,000. And now you can get a computer, like a $2,000 computer with like 32 gigs of RAM. So yeah, so memory isn't an issue. MATLAB has been around for a long time, but again, it's based off of C, and C allows you to change how you define how much memory is used for a variable. So in case that does come up, you can look up more about that. But that's what the double, you see single only uses half as much memory as double, so it only uses 32 bits of memory. So the number is half as small that it can define. Just to make sure that you guys know that. Now, again, one more thing that I want to talk about, importing data into MATLAB. Okay, so there may be a time where you already have a matrix of data, or like say like a spreadsheet or a CSV file of data that you want to perform calculations on, okay? So in order to do that, we need to import the data into MATLAB. So MATLAB can deal with basically almost any type of spreadsheet. So whether it's from Google Sheets or Excel, or like I said, if you have like a comma separated variable file, CSV, then you can definitely import that into MATLAB. So let me find mine. Okay, so I already have some files uploaded into my the cloud for MATLAB for my account. If you want to upload files, beforehand, obviously, if these weren't here, then you would go to the Home tab and then click on Upload, and then it's just a matter of finding the file in your what is this? Excel. Let me see real quick if this is actually something I can execute into or import into MATLAB. No, that is not. Okay. That's fine. But yeah, so you would find the spreadsheet, just click open, and then it will import it into MATLAB. And then let me go over here. So I'm just opening it right now. Okay, so I'm just going to show from the IDE version. So once you click on open, MATLAB will open it up in a separate window. In the online version, it will just open it up in a separate tab. Let me open up one right now. And then you'll get a an import tab. Okay, so nice thing is that MATLAB is able to detect. Usually your top row is going to be naming your columns. So MATLAB will be recognize that. And if you have the row a column here with all the rows named, it will be able to find that as well. So it will only highlight the text. Then you're able to choose like what's imported in. So say we only wanted like the first 3 rows, then you can come up here and then change that. So say I only wanted like the first three columns, then you can highlight that and then import it that way. When you go to import, okay, I'm sorry, it's different in the IDE version versus online. So now we need to tell MATLAB once it imports it how to define that matrix or array of data. So up here we have type, okay? So we have different ways that we can define the data that we're coming in, and that's going to change how you're able to interact with the data. So we see down here the 3 columns that I imported in. It made it be a 330 by 3 table. Okay, so tables are like a certain variable type in MATLAB, and basically I would not use table. They're considered like structures, and so basically I'm not even going to talk about that right now because I just don't have enough time. But basically, if you want to import the data, so it's just like a 4 by 5 matrix, or in this case like 330 by 3 matrix, then you either want to do column vectors or numeric matrix. And that will actually make it into something that here we try one more time. Okay, so if you choose column vectors, it will actually separate each column by itself. And then if we choose numeric array, yes, that is what I meant. Okay, so see, when we use numeric array, it actually has, it's a 300 by 33 double, and then it has the matrix icon. So then that we'll be able to use it. It would just be like the matrix that I made, like the 4 by 5 or the 5 by 5 matrix. And so if you double click on it, it actually shows it as a regular matrix. It's showing NaN for here because there weren't values inputted, and I still had those selected. I didn't take them out, so that's why those are there. Obviously, I want to fix that before actually trying to use this data for computing whatever computation I was going to do. Okay, so that's basically what I wanted to talk about for MATLAB. Like I said, there's still a whole, this is just the tip of the iceberg. There's still so much to talk about. Like I said, there's courses you can take a whole entire semester or even multiple semesters about MATLAB. One more thing, just one thing I want to mention, MATLAB actually, as a company, has a really good resource that if you want to go in on your own to practice MATLAB, obviously you would have to make sure that you link your account first and get verified with the MATLAB, your CSU email address to allow you to use this. But once you do, if you just Google MATLAB Academy, they have like a full course. And so the on-ramp, as it states, get started quickly. So anything that says on-ramp, it's just like it's just like I did. It starts from like zero knowledge, right? And it'll take you through step by step. It uses the live text editor, and then it will bring you through examples and ask you to do try and execute the commands yourself, use the functions. So MATLAB Academy, if you want to, like I said, it's there. All you need to do is link your account to be able to use it, and it's definitely really good. It has videos, so that is that. So one last thing that I want to show is Simulink real quick. So Simulink is I'm not sure if anybody has heard of LabVIEW before, but because I learned LabVIEW before I had learned about Simulink, and it's basically the same thing. So what it is that you have functional blocks that are predefined by the Simulink program. So you know, you have a block that does gives you a sine function, or a block that multiplies by a certain number, like a gain. Just bear with me, I'm trying to find something real quick. Here we go. So what you have to do is find these blocks, or find the blocks that you want, and then add them to your Simulink window. So I'm bringing up a very simple Simulink right now. Just give me a moment while it loads. Okay. So there's no text, although you can add in text, but it works off of like flow charts or like functional diagrams. Okay, so in order to get these blocks, you can either go to the library browser up here, and it'll bring up a separate window and show you all the different. Try that again. All the different old blocks that are available. Do I have too much open right now? Sorry, just bear with me. I don't know why it's not. There we go. Okay. Okay, so here it has like a library of all the different blocks that you can use. So here it has it broken down by categories. So here we see commonly used blocks. So, you know, there's some pretty sophisticated simulations that you can create for at Long Beach. The first time that I used it was when I took 350 for power. And we were like, they had us create Simulinks for to model like generators or transformers. I wonder if I have. Yeah, I'm sorry, I don't remember where I have them saved, but we'll just stick with this. So yeah, so once you find the block that you want to use, then you just click. And you can click and drag, and then it will add it to your Simulink window. Another way that you can interact with it, instead of just using the browser, if you double click and you know what block that you want, then you can type in the type of block and it will automatically search for it. So then if I type that in, we see that I have a block that's exactly the same as the one that I dragged in. So if you know what type of block that you want, then just double clicking and then using the auto search feature here, as long as you have block selected, because you have actions, then it's gonna just create text in your window. But then you can search for it that way as well. So just real quick, let me run this. So what I'm basically doing here is that I'm inputting a sine wave that has been discretized. So instead of it Simulink treating it like as a continuous signal, it is like a vector of points. Okay, so that's what this is doing right here. And so we can see that you can have one input and sent to multiple inputs as well. So you know, the branching can get pretty elaborate. So actually, let me go over the branching real quick. So if you want to connect something, then you know, you just click either on the little caret here, and then you can click and drag, or if you know exactly where it's going to go, click off. Or if you know exactly where it's going to go, then you can also start from the other side and then just click to the line and do it that way. So you don't have to drag it if you don't want to. It might be a little bit easier. So it's just basically, as long as you know what functional blocks you want to use, then it's just a matter of like connecting the dots, right? So Simulink, it can be easier, but then it requires more foresight so that you actually know what you're trying to do. So these triangle blocks, they're called gain blocks. So basically what it means by gain is just that you're multiplying it by some number, right? Because with signal processing, if you're applying a gain to something, you're basically multiplying it by some amplitude, okay? So in this case, I'm taking the values and I'm multiplying by a gain of 0.001. And then we're taking it, and so this is called a summer. So with the summer block, you can define whether you're adding or subtracting. So say, and it's done in order. So since it's a circle, you can also change the shape if you wanted it to be rectangular. You know, you hit apply, do it that way. That might be a little easier to see. So if I change one of the plus signs to minus, we see here it changed the sign as well. So now this branch is being subtracted and this sign is being added. So and again, it's done in order. So if I had, oh, that's not what I wanted. So if I come down here where I have more branches, okay, you see I have plus, minus, plus, and then so that's how it's defined. So it's done in order. If you have the circle, it does it counterclockwise from top to bottom, or from left to right. And then if you have it as a rectangle, then it just goes from top to bottom because it's going to be, you know, in one column. Pretty simple. So we just have a summer. So again, I'm sorry, I didn't explain what this was doing. So this is just showing, taking the sign, and then this is calculating the integral for it numerically, since I'm dealing with discrete points and not with a continuous line. There's various ways that you can numerically compute like the integral or the derivatives. Just for, I guess, completeness, this is doing it like the backwards Euler method. So basically you have a value, right? You subtract the previous value from the vector, and then you output it out. So basically we start with a value. So whatever, you know, the start of my sine function. And then with each time that it iterates, you know, that it performs the loop, to find the integral, it subtracts the previous number, and then adds the previous number from the current element, and then outputs it out. And then that's how you would calculate the integral. And then these are showing the derivative and the second derivative. So now what I'm going to do is that I'm going to run. So up here, you can define how long the Simulink lasts for. So I'm only setting it for 1 second. Obviously, if you wanted to do it longer, then you just define how many seconds that you want it to run for. And then, okay, so if you go to modeling and you go to modeling settings, you can also define like simulation time here. Obviously, there's a whole bunch of other settings that you can adjust. So we see here that I actually chose backward Euler because I was using this as a test. Since this functional block right here does take the integral as well using the backward Euler method. So I won't go into all of this because, you know, we obviously just don't have enough time. But if you also wanted to hard define the simulation time, then you can do that here as well. Let's go back here. So I'm going to run this. And then, so these blocks right here with the, I guess like the pill shape or the oval are outputs. Okay. Now, there are different ways that you can output the data. You can actually output, because Simulink and MATLAB can work together. So what you can do is that you can create a model with Simulink, have it output the data as a vector to MATLAB, and then in MATLAB you can perform calculations however you set up or whatever you're trying to do. So I just ran it and it finished executing. Now, if you have these they just call them outputs. These outputs, because the ones where it outputs the data to MATLAB are different, it will, to be able to see this data, one way that we can bring it up is to go to Data Inspector. Now, you can only use Data Inspector as long as the, let me minimize this, as long as you have these outputs. If you have a different, let me find the other one. The output that goes to MATLAB, then it is not going to work. I'm just trying to find that block real quick. Where is it? Okay, I would have to double check that because I can't find it right now. But let me show you the outputs for the Simulink. So again, we're going to go to Data Inspector, and then we see all the different outputs here are showing on our graph. Now we see that we have more lines here than the amount of outputs that I have, because I technically only have 4 outputs, because that's how many of these out blocks that I have. So the reason that there's more outputs is because I have these little, I guess, Wi-Fi symbols here to allow me to output. So what I'm doing is that if you click on a line and then you let the ellipse come up, all you have to do is just hover your cursor over the 3 dots, and then you'll get this little menu. So I'm going to enable data logging, and when I do that and I go to the Data Inspector, it will output those signals to the Data Inspector. So then if I want to see them, it's available for me. And then that's really good if you're trying to, again, do troubleshooting. So if you're just trying to set up like a certain model or Simulink for the first time and you're not entirely sure how it should work, or if you're having trouble with getting the correct output that you want, then using the Wi-Fi symbol to add additional outputs, you can see what output is showing at that particular line could be, or branch could be, really helpful. So I'm just going to show my outputs. They're all different ranges, so I will just do one at a time. So our original was just a sine wave. And so we see here, we have our integral, and then we have our first derivative, and then we have our second derivative. So this weird line here is just based on how, because remember, we're taking the first element of our sine wave that's been discretized and then subtracting it. So that's why it has this weird blip here. I would say the function should be, or these functions should be pretty self-explanatory. We have a magnifying glass here, so I can just choose and zoom in on a particular part, and it'll do that for me. If I just do it like zoom in, like if I click and hold and drag, then it will zoom in just on a particular axis and leave the other axis alone. So again, if you want to zoom out, and then if you click on the square here, it will readjust it to show the whole entire graph. And then you can save your data. If you want to import or export it, you can do that here as well. I know that wasn't a lot of time, and you probably still have a lot of questions about a Simulink. Honestly, your best bet is probably just to, open it up, play with it. I mean, that's true with anything right here. This is an actual class, obviously, but our time is up. I know